Hello and welcome to MLC CAD Systems 3D printing webinar. My name is Amelia Parada and I'm going to be hosting this webinar for us today. Today we're going to be focusing on leveraging your Markforged products as effective and efficient tools. So we're going to go ahead and go over the agenda. First, we're going to establish the value of 3D printing in-house and how you would convey that to your management team. We're going to find multiple applications for 3D printing among different departments within your company. Number 3, we're going to find alternate applications with the assistance of MLC CAD Systems and how we can help you save money and increase efficiency. And 4, finally, making your way towards parallel production, which is where we see a lot of our customers heading. Number 1, we're going to establish the value of 3D printing. 3D printing is really getting into the realm of production. We're seeing a lot of our customers buying 3D printers, specifically the Markforged product line, to utilize them on their manufacturing floor. Saving time and offloading their machines to reduce costs for the production machines that can actually be used to make them money. The cost savings for the cost savings for this by producing standard fixturing and tooling is tremendous. We see a lot of our customers. We're actually going to be talking about some of those case studies in the webinar today, but for the most part, the cost savings and the time savings are really substantial. The first step is to calculate the ROI. We're going to calculate the cost of your printed part. I'm going to use an example. We're going to determine the cost for an alternate production. Find your breaking point. Develop an ROI and the value of 3D printing. And then finally, calculating your ROI. The first step to determining the ROI of your 3D printer is calculating the cost of materials per part. The Eiger software, in fact, does this. It provides material estimates to simplify this process. The total cost of this brake lever that you see here is $58.83 if you printed it in the onyx material and the carbon fiber. Much of that expense is due to the continuous carbon fiber, which reinforces this brake lever to be just as strong, if or more than aerospace grade aluminum. With the same file and fiber routing optimization for fiberglass, the number changes a bit, down to $23.80. That's printing in the onyx material and fiberglass. Versatility really does afford you the cost savings. By understanding the strengths, properties your part needs, you can use the continuous fibers efficiently to cut down on the costs. Number 2, determining costs of alternate production. It's time to compare the cost of other manufacturing methods, such as CNC milled, traditional manufacturing methods that you see here. For this particular brake lever, it's going to cost you around $195.95 per unit. And that's if you only went with 100 units. Now, of course, if you get more units than 100, you're going to be saving and cutting on that cost a little bit more. The cost varies depending on the machining and the services. By comparing the two processes, it is immediately clear that 3D printing is the less expensive option, saving yourself about $140.89. Step 3, finding your break-even point. The $140 that you could be saving with each prototype, tool, or product you send to an external machine shop builds up, and you can speculate how many parts it will take to break even. Assuming you only print the one part, the brake lever that I've been using for this example, the machine that we have for this example, the Mark II, $13,499, it would actually your break-even point would result at 96 parts at that point. Step 4, the value of 3D printing. The same brake lever used earlier has a tooling cost of $2,865 for an injection molding type. If any modifications are made to that design, that cost must be included with each design change. The price of a 3D printer you only need to pay once, while tooling and prototyping costs are required for every design otherwise. So every change, every part that you're looking to evaluate and make with your CNC machine, the cost varies and the cost increases each time. Finally, calculating your ROI. Your ROI can be calculated with information about overhead tooling costs from other fabrication methods and the cost of products your printer may produce. But the more important parts you print with each new design, each iteration, your Markforged 3D printer can push product development to be more time efficient and cost effective. The calculations that you see to the right is the actual formula for you to be able to provide your own ROI if you would like to. "3D printing in different departments." We have found, as we've started talking to different customers, 3D printing can in fact be used in your manufacturing department, your engineering department, sales and marketing, prototyping, R&D, all with your Markforged printer. We're going to actually be taking a look at each of these departments and providing a case study for each. The case studies are all unique to the specific customer and can actually be utilized in multiple areas, not just manufacturing or engineering or sales and marketing. So they kind of overlap a little bit. However, we do see that a lot of our customers are being able to use their Markforged printers in all of the departments that you see here. The first case study that we're going to be discussing is the manufacturing. Fuel injector soft job by this particular example was printed in onyx with with fiberglass reinforcement. Fuel injectors require precision machine bores for tight seals on mating faces to prevent leaking. Markforged machines allows users to print accurate, strong soft jaws for precision boring on a CNC mill. The onyx material resists corrosive cutting oils and lubricants, while continuous fiberglass reinforcement withstands significant vice and tool forces. Typical machined aluminum soft jaws require expensive and difficult machining and deburring to achieve the appropriate geometry. One thing we really want to focus with this particular case study is the turnaround time. If a customer were to machine that particular soft jaw, the standard process would take about 2 weeks. With a Markforged printer, it takes about 32 hours. So you can set that printer up to print over the weekend while you're at home spending time with your family. In many facilities, they employ coordinate measurement machines, CMM, inspection fixtures, to measure specific locations on a component, while the part is typically held in place by a modular system of posts, clamps, and stops. So that's multiple pieces for that particular fixture. A Markforged printed fixture offers a significant improvement over these standard kits. Setup time is minimized as the entire fixture can be printed in one piece, replacing a pile of traditional fixturing hardware. Useful for any facility with CMM or optical scanning quality checks, a Markforged printer can greatly increase the reliability of the quality control center. For this particular case study in engineering, the assembly time is something that I want to take notice. Standard process typically takes 1 to 2 hours. For this Markforged printed part, it took about 5 minutes for setup. Sales and marketing. For the first time, parents, whether or not their baby is sleeping well is almost always an area of concern. Rested Devices, a startup company, has the goal of creating a nursery at the age of the smart devices. One of their biggest product developments, Mimo, is a wearable device for infants that monitor a baby's sleeping patterns, breathing, and movement, and update the parent on their child's health through a smartphone app with live data. This small startup company, Rested Devices, 3D printed the first iterations, then finally production, tooling and fixturing to keep production costs low. So they were actually able to work with their sales and marketing department to help push this particular device, even though the part was printed, the tooling and fixturing and the additional fixture, the final product was printed on a Markforged printer. They were able to utilize their sales and marketing department to help put this information out, to market it to families who are wanting to communicate with utilize their smart devices and keep track of their baby's sleeping patterns. Prototyping. Windows and protective barriers for heavy grade coaches and buses make up the main product line for Aero Global. New product design engineers search for ways to improve and expand their product line. With that comes the need to improve Aero Global's prototyping stream to be a more cost-effective process. Their designs with their designs, they were able to print it and make changes to that design, print it again, and then make another change. Markforged vastly dropped prototype costs and lead times, while it could increase both end product efficiency and production times. Martech is a company that uses Markforged to print water intakes for their autonomous aquatic vehicles. You see here at the bottom, we have multiple different options that they have designed. By using onyx material, Martech can design a geometrically complex, highly functional part. The print intake is 30 times cheaper and 18 times faster with the Markforged technology, and the onyx is robust enough to survive debris and corrosive seawater. So they were able to print their part in 8 hours versus 144 hours, and that was equal to a 94% overall savings. Alternative applications to saving time and money. Ways to go about this. Utilize us at MLC CAD Systems. We offer a service called Walk the Line after we have had multiple qualifying conversations about where you plan to take your 3D printing. Our application expert is trained to go into your facility and help you determine alternative applications, because not only are there jigs, fixturing, and tooling applications, but there are multiple other options that you can go about by using your 3D printer. This is what we're here for, and this is what we want to do to help you. You're saving time and money compared to traditional manufacturing methods like fabricating and machining. However, that's not the only thing that you'll be saving. You're going to be not only saving on the time it takes to get your entire staff up to speed on utilizing a 3D printer, but the seamlessness and the ease of use that Markforged has to offer with their 3D printers is something that across the board has been very, very positive. Manufacturing methods that require a large number of fixtures can now be can now be printed. So if you have fixtures that you only need 50 of, that's considered a larger number than compared to making 50 of those multiple parts. You can make 50 of those single fixturing, like I had explained in our engineering example prior to. So the future is really moving towards parallel production. Many manufacturers have realized significant cost savings and productivity improvements by integrating high-strength 3D printing technologies into their business, especially in support of their maintenance, repair, and operation strategy. Does your company have one of those? 3D printing has been hailed as the future of manufacturing for years. Instead of using it to replace existing processes for end-use production, manufacturers can leverage high-strength 3D printing to complement existing technologies in their maintenance, repair, and operations efforts, dramatically reducing the cost of factory tooling. Today, we're going to go ahead and look at 3 paths that you can identify within your business to help with making your way towards parallel production. There are 3 identification paths to discover the cost savings of high-strength 3D printing in your MRO toolkit. Viewing your operations through these lenses can help identify the high-value opportunities in your process, which can form a strong foundation when building a return on investment analysis of your 3D printing strategy. Path 1, pain points and cost drivers. Unplanned line shutdowns due to equipment failures are some of the most costly aspects of a manufacturing process. Identifying applications for additive technology on your factory floor by going to the source of the challenges. High-strength 3D printing can be used to quickly produce replacement parts or custom alignment jigs, making these challenges excellent starting points for building 3D printing strategies. Sorry, that was a quick transition. So one thing I want to talk about is the picture to your right. If you work on the factory floor, you probably have seen an example such as this. A reoccurring source of line efficiencies is cardboard engineering, which is a picture of that right here. Solutions to configuration challenges that utilize cheap and temporary materials like duct tape, zip ties, and plastic sheets. This is no longer a problem. You can use your 3D printer to print certain things that you can design in-house to help with cardboard engineering. Compare this with additive or with 3D printing solutions, which can produce unique parts with integrated alignment features for quick and simple positioning during line changeovers. Path 2. Many manufacturers have found success driving down tool costs in their factories by leveraging high-strength 3D printing. Many of the largest cost savings 3D printing opportunities in manufacturing are produced in low volumes when compared to the number of parts they are used to produce. And finally, path 3. One of the broadest ways to discover potential cost reductions with 3D printing is your plant. In your plant is to search for a few key plastics and materials that are common in your MRO or manufacturing tooling. The strength, toughness, and wear resistance properties that make these materials ideal for the factory floor can be replicated or exceeded by those of Markforged printed composites. Modern manufacturing requires new tools and new perspectives in order for your company to maintain a competitive edge. 3D printing can dramatically lower the cost of tooling and parts used in maintenance, repair, and operations. Many manufacturers have seen huge improvements to the competitiveness of their operations by leveraging high-strength 3D printing solutions like Markforged Industrial Series printers. Advanced printing materials, including continuous carbon fiber filament, reinforcement of those parts to achieve strengths exceeding aerospace-grade aluminum, and enable geometric complexities beyond the capabilities of the 6-axis machine, all controlled by a powerfully simple printer management software that requires no CAM or CNC programming. The Markforged Industrial Series is a critical tool for cost reductions and capability improvements in your manufacturing strategies. So I'd like to thank everyone for attending the webinar today. Here's my contact information. You can reach me if you have any questions about how to get yourself towards parallel production or any of the case studies that you do see. I am also on Instagram as well as LinkedIn. So if you want to stay up to speed on the latest that we're doing here at MLC CAD Systems, I am posting often and keeping everyone up to date on the cool things that we are printing over here.